Right, last video of the day. Question C, are the number of tiles increasing at a constant rate? This is going to be the same answer as it was on the front side. So no, it is increasing, but not at a constant rate. So no, it is increasing, but not at a constant rate. Question D, what do you notice about the second rate of change of the tiles? And remember, the rate of change of the rate of change is what we call the second rate of change. So here I have drawn only the first, but if we take a look at the second rate of change, how do I go from 5 to 7? I'm going to add 2. From 7 to 9, I add 2. From 9 to 11, I add 2. So once again, we have a constant rate of change, and that would be 2. So there is a constant increase of 2 each time. All right, draw a sketch for figure 100. Determine how many tiles will be in figure 100. Show how you arrived at your answer. So I'm going to bring this down a little bit so we can see those tile patterns once again. First thing we know is we've got a square. Oh, this is figure 100. So we have our square, and once again our square is green. And in the tile pattern, figure 1 was 2 by 2, figure 2 was 3 by 3, figure 3 4 by 4. So that number was always 1 more than the figure number. So if the figure is 100, what's 1 more than 100? 101. This is going to be 101 by 101. Right. We always are going to have that purple tile that sits on top. So that one purple tile that sits on top. And we also have the arms. We're going to have the arms sticking out right here, and an arm sticking out over here. And if we look back at our old tile patterns, the arms were, once again, 1 more than the figure number. So if it's figure 100, 1 more than 100 is 101. So there's going to be 101 on both sides. So then in order to find out how many tiles, we just have to add everything up. So the first thing we're going to have is the square. So 101 times 101. So that'll be how many green tiles right there. 101 times 101, base times height. That's how we find the area of a square. Plus 101. Plus 101. Plus 1. And I'll underline this real quick. So we have the green 101 times 101, plus the pink 101, plus the orange 101, plus the purple 1. And when I figure that out, first thing I have to do is multiplication because of order of operations. So 101 times 101 is 10,201, plus 101, plus 101, plus 1. And when I put into my calculator 10,201 plus 101 plus 101 plus 1, I'm going to get 10,404. So that'll be 10,404 tiles in figure 100. And drawing a generic sketch of figure X is very similar to figure 100. So figure X. So first we're going to have the square. And if we remember, the sides of this square are always 1 more than the figure number. So what's 1 more than X? Well, think about translating that. 1 more than X. What's more mean? Plus. So this side's going to be X plus 1, and this side's going to be X plus 1. We have our arms here. Remember, these were always 1 more than the figure number as well. So if we have figure X, it would be X plus 1 and X plus 1 on each side. And last but not least, we have that one purple tile that is sitting on top of the shape. So there's one tile there. So my equation for this one is going to be a little bit more difficult. So my pattern will then be X plus 1 times X plus 1, plus the pink, which is X plus 1, plus the orange, which is X plus 1, plus the purple, which is 1. So when I simplify that, If I do x plus 1 times x plus 1, that's the same thing as saying x plus 1 squared plus x plus 1 plus x plus 1 plus 1. And then we'll just have to combine like terms here. So I've got two x's. So x plus x is going to be 2x. And 1 plus 1 plus 1 is going to be 3. So plus 3. All right. So x plus 1 times x plus 1 is going to be x plus 1 squared. Then we've got x plus 1, and 1. Combining x's, we get 2x, and combining just the 1s, 1, 2, 3, we get 3. If you have questions on that, though, please raise your hand, let me know, and I'll help explain that a little bit clearer to you. Question G, use your equation to determine how many tiles there would be in figure 57. So once again, I have the equation y equals x plus 1, that squared, plus 2x plus 3. Let's plug in 57 for x. So we have 57 plus 1 squared plus 2 times 57 plus 3. So order of operations says I do parentheses first, so 57 plus 1. We get 58 squared plus 2 times 57 plus 3. Continuing my work over there. Next step is, for order of operations, is exponents. So we're going to do the 58 squared. And I get 3,364 when I do 58 squared. So plus the 2 times 57 plus 3. Next thing in order of operations is multiplication. So I'm going to do 2 times 57. So when I do 2 times 57, I get 114. So I get 3,364 plus 114 plus 3. And finally, when I add them all together, I'm going to get 3,481 tiles. And last part, question 3. Carly found the rule y equals, it is copying missed something, so it should be x plus 2 in parentheses. So y equals x plus 2 in parentheses squared for the tile pattern problem 2. Does Carly's rule work? Explain. If we want to know if this works, we're going to have to test a couple. So we know we can plug in a couple of these numbers. So if we plug in 0, we're going to get y equals 0 plus 2 squared. 0 plus 2 is 2, and 2 squared is 4. So that did, when we plugged in 0, we did get 4. So that one checks out. Let's test another one. Let's test 3. Y equals 3 plus 2 squared. Y equals 5 squared. Y equals 25. Okay, that also checks out. So up here, 3, when we plug in 3, we get 25. When we plug in 0, we get 4. And let's just test this one way over here, see if this works. So we're going to plug in 7, and we're going to see if we get an answer of 81. So y equals 7 plus 2 squared. Y equals 9 squared, and y equals 81. So yes, that does check out. That matched the value we had in the table. If we check it 3 times and it works, that's pretty much a guarantee that it's going to work for every single number. So I usually, if it's asking me to test it, I'll always try 3 different numbers just to make sure it works. So how do we think that it works? Go ahead and write a quick statement. Clearly this x plus 2 squared looks nothing like this equation from part F. So just note right now, stuff might look a little bit different, and that's okay. You might get something different from your neighbor, and that's totally okay as long as we get the same answer, as long as it checks out just like this checked out. Later on in the semester, we'll figure out a way that we can simplify it so that it looks like this every time and everybody has the same thing. But for now, it might be different, which is totally okay. If you finish this, go ahead and start your homework, and have a great weekend.